Perfect. Good. So the next 15 to 20 minutes, I'll speak about how we at NVIDIA quantify user experience. And we've been working on ways to quantify user experience for quite a long time. And I'm very happy to hear the other TeamRGE members with their projects working on user experience, because I completely agree that user experience is key to a successful deployment. And while it is important to quantify user experience, and try to have hard numbers or have hard numbers behind it, subjective user input and feedback is as important, maybe even more important. So just really happy to see the focus on user experience when it comes to VDI and RDSH, of course. Okay, so this comes from a marketing team, but I kind of like this slide. It shows how the operating systems have changed over the many years. I really started working with Windows in the, I think my first computer was in Intel Pentium 75 megahertz, had Windows 95 on it. But you can see that operating systems and also applications over time have just become more graphics intensive. And the point being is that we're just moving to an era where we just expect visually compelling or applications, and we want to have an easy way to use application that is the output of that is just more and more graphics consumption. This graphics can be executed by an emulated GPU served by the CPU, or you can put a virtual GPU based on the NVIDIA technology behind it, or even attach a physical GPU, which is not necessarily the most cost-effective solution. But there are many ways to add a GPU, and they all have their benefits, and they sometimes work and sometimes they don't work, and why you want to add more and more GPU resources towards it. So when I used to speak, and when I still speak to customers, I often hear the goal in a VDI deployment or an RDSH deployment that, hey, we want to have at least as good a user experience as a local environment, and actually even better. And what I try to tell my customers that I work with is that I completely understand the goal. But if it's an apples to apples comparison, a remoted desktop just shouldn't be or can't be as good, if you're assigning exactly the same resources, because you're adding remoting to it, and there's a little bit of latency that you're adding to it. So while it's the goal to provide the best possible user experience, a local PC or workstation is because it doesn't have remoting, because it has dedicated resources, you're not sharing any of the resources with any users, it will still be the best user experience, unless you do an apples to oranges comparison and share different or assign different resources. So a VDI desktop then has you share resources, it doesn't matter if it's a GPU at this point, or a CPU, or the IO, or the storage, whatever it may be, but you're sharing resources, and there has to be, the hypervisor has to schedule resources, et cetera, and as already mentioned, there's an increased end user latency, There's a remoting part of it, there's a networking part of it, All that has to be done. And then there are remote protocols, and we've heard, already good content from Cody and others about that remote protocols do all kinds of things to optimize, And optimize can be interpreted in different ways now, but they optimize for frame quality and to quantify to save other resources, They might try to save on bandwidth, and they might lower the image quality, which in many cases really makes no difference, but sometimes it does. So you will not get the same on a physical PC. There's no network in between, there's no remoting in between, so you always get the perfect frame. So while I completely understand, and I think it's the right thing to do, and don't get me wrong, optimizing and saving bandwidth and lowering quality makes a lot of sense. It sometimes is, It doesn't pan out the way that we want it to. Okay, so what we do at NVIDIA is we try to measure a couple things. So we look at the number of frames that are displayed at the endpoint. So we really, similar to what Benny has mentioned with his Rex tool, is we care about the frame rate and the number of frames and the quality of the frames that are displayed at the end user, at the endpoint, because that's what ultimately matters, right? Not necessarily what is inside of the virtual machine running on the server. So we measure, we count the number of frames that are displayed, not the ones that are being presented like fraps and others. We actually look at the ones that are displayed. We measure the end user latency. And this is, right, and basically describes how remote the session feels or how interactive or laggy the session is. So it's a measurement of latency, but it doesn't, while it includes the network latency, it also includes the encode time, the application rendering time, the user input time, et cetera, et cetera. So it's a true value of what the end user feels when he interacts with that system. We also measure the image quality. So we compare the frames that are being generated on the virtual machine with the frames that are being displayed to the end user in order to understand what the impact of the remoting protocol is, right? And that's not necessarily a bad thing if it doesn't match up. Something that we don't really measure is functionality, but of course, right, if you attach I'm just going to take the example of NVIDIA vGPU. If you attach an NVIDIA virtual GPU to your virtual machine, there are certain things that you can run, certain APIs which are now supported, which otherwise wouldn't be working, CUDA being an example, right? Maybe even the latest versions of OpenGL and DirectX. And then consistency. Important while defining user experience is how does your user experience, or how is your user experience across right, the time of your work. So we would rather have a consistently good user experience in comparison to sometimes a great, fantastic user experience, and then in the next moment a not so good user experience. Right, consistency is important. So what we do is, and all the metrics are measured at the endpoint, right, because it matters what is actually visible to the user and how it feels to the user. So first is we have a way to measure end user latency. And when we run our test independently of what workload it is, because these metrics are not bound to the workload itself, we're able to measure the end user latency. And what we've done is we've built a tool, a software tool that allows us to input into the remote desktop session, which then measure see when the change is observed by the user. So we measure that time and we get a good understanding, a very accurate understanding of what the latency is, independent of what the application is. So if you're interested in understanding how the latency is for running a web page, right? Let's say an OpenGL, WebGL content, and then want to open a static website, we can do that now, right? So that's one way. We measure the frame rate, as I mentioned before, and I hope you can see that this through GoToMeeting. Frame rate matters, right? If you are typing, as an example, if you don't have a high frame rate, there's a high chance that you will have typos. You're going to use the backspace, and you're going to use it inadequately wrong in terms of the number of backspace you press, because you think you're at one point in the word, but you're actually at a different point. And then we also measure the image quality, as I mentioned before, and we use two different ways of then quantifying the image quality, SSIM and PSNR, to really get an understanding of what the impact of the remoting protocol is. So the important point here really is these three metrics are measured at the endpoint. We measure them at a constant basis. So, right, if you have an end user latency, we measure every 5 seconds, frame rate every second, and image quality not that often because it's a very processing intensive workload. When we do testing, we have a workload that we test with. We use what we believe is the most common browser, or is the most common browser today. We use Google Chrome. We have we have web pages of various different kinds, static, HTML5, WebGL, etc. But we try to make it as realistic as possible. And from the customers that we've been working with, we're hearing very good feedback. that is a real life example. And then we use, right, the typical other applications, which I think make up a knowledge worker / digital worker, right? The Office suite, we play a little bit of video playback, but we do that in Chrome these days, actually, not in Windows Media Player like the slide says, because we believe that most customers today play videos in Chrome. And then very similar to other tools out there, right, we input at human speed. We have interactions between the applications. We copy and paste between the applications, et cetera, et cetera. So end user latency, I do want to capture this one really quickly. As I mentioned before, we're able to trigger a input, which is a mouse click, and we start a timer. This mouse click is then taken by the remote protocol and sent to the virtual desktop or the RDSH session, right, right to the VM, wherever it may sit, on-prem or in the cloud. It triggers something, right, whatever application it might be, and then we observe at the endpoint the change. And then we stop the timer, and the difference between those is really our end user latency. And of course, that incorporates the encode time, the decode time, the frame rendering time, the network latency, et cetera, et cetera. So that's a way for us to measure end user latency. Image quality I already mentioned, so I'll just go briefly about it. But on the right-hand side, you can really see a heat map. So that's our way to visualize, right? There's actually a value behind it, but this is a way to visualize for the reference image on the left-hand side, the difference between using two different protocols. And you can see, right, the left one has a much higher SIM value, so 0.995, and one, by the way, is a perfect image, whereas the right one has a 0.96, which is already a big drop in image quality. And you can see, right, all the greens and the dark reds, et cetera, there are changes. So if you were, and Cody, I think, mentioned it before, if you were now to compare a lot of text and you were to compare YUV 444 and 420 as an example, you would see the text really showing up depending on the colors, because, right, YUV 444 is much better in for text than 420 is, as an example. Okay, so we've done, and right, I do want to state before sharing any data is, right, whatever we measure is measured with a very specific configuration, right? And if you change anything in the stack, in the workload, in the configuration, right, the numbers will show very differently. So here we tested, we had a HPE SimpliVity box in the lab, and we ran Citrix Virtual Desktop, the 1808.2 version with Windows 10, 1803, and we ran our knowledge worker workload, which has, right, the applications and workflows in them that I mentioned before. So Excel, Word, PowerPoint, Chrome browsing with WebGL, PDF viewing, etc. And we tested with a dual 1080p screen, and we measured, right, our usual metrics. So end user latency, image quality, frame rate, and we also looked at the utilization on the server. And what we found out is that we saw a 10% improvement in end user latency. We saw that the image quality, right, is as it's supposed to be, right? A GPU doesn't necessarily change the image quality; it just does the encode now on the hardware encoders on the board. So we expect very similar image quality unless the remote protocol vendor now does, right, use different settings. We saw an increase of 15% in terms of, this should actually show, say, displayed frames, not remoted frames, so frames that are that were seen by the end user. And on the server, we've seen 30% lower CPU utilization. So again, right, but just because and I'm just going to take the example of CPU utilization, just that because we saw 30% lower CPU utilization doesn't mean that everybody for every workload, for every configuration will see 30% lower CPU utilization, right? If you run a different workload, if you run with a different number of screens, with a different resolution, a different remote protocol that, for example, doesn't use hardware encode, right? These numbers will change. And if and how much CPU difference you will see will depend on your stack. So, right, make sure that you test with exactly the configuration that you are interested in. Okay. So again, and I just want to sorry, want to stop here, but the summary really being is the opportunities, the customers that I've worked with where we were successful were the customers that actually cared about user experience. Customers choose NVIDIA GPUs, or those customers have chosen NVIDIA GPUs because they wanted the improved user experience. They wanted to be able to future-proof themselves. They wanted to be able to serve WebGL content and the changes that are going to come in the next years within the OS, within the application. Those are the customers that are most likely to choose the GPUs for those workloads, right? And they've been happy with them. Focusing on user experience has been key. And I think that's kind of also what others have been saying before, right? User experience matters. And if you don't provide an environment that provides good user experience, people will not use it, and most likely your deployment will fail over time. So, people are used to good user experience today on their phones, on their basically on every device. And one reason, not the only one, but one reason why why the user experience on those devices are great is because they have a GPU, right? My phone has a GPU. I'm sure your phone has a GPU. So let's provide them similar user experience when they do a remoted desktop or remoted session, via RDSH. I will stop here. I'm going to be available for the Q&A if there are any questions. Otherwise, please feel free to contact me via email, via Twitter. More than happy to help out. And thank you everybody for listening, and for the others for making this event happen.